In this video, I'm going to be explaining about the n-queens problem using hill climbing algorithm. For this scenario, you have to take an n number of queen with n cross n chessboard, and you have to place all these queens in such a way that they don't attack each other. So for this scenario, I have taken a 4 cross 4 chessboard with 4 queens. So I have to place these 4 queens in this 4 cross 4 chessboard in such a way that they don't attack each other. We can say that a queen won't attack each other if they are not present diagonally or adjacent to each other. So if there's a queen right here, there shouldn't be any queen in this direction, or this direction. So let me explain this scenario. Before that, let's understand what an hill climbing algorithm is. For an hill climbing algorithm, we have 5 steps. First being the initial solution. That is nothing but the positioning of your queens in the initial position. So where you would place your 4 queens in the initial position. Then once you have placed them, you have to evaluate the quality, in the sense the initial positioning matters a lot because that helps you decide whether you will get your final solution quicker with a less number of steps or not. The third thing is neighbor generation. Once you have selected your initial solution, for each of the queen, you have to see what is the next move you can make for it. Based upon that, you can calculate a heuristic value. In this case, the heuristic value will be the number of attacks. And once you have satisfied all your condition, then you can terminate. That is when the condition is met. Our condition here is that no queens should attack each other. So as I mentioned, the heuristic value here is nothing but the number of attacks. So our goal is to bring the heuristic value to 0. So now let's start. So the initial solution, I'm going to be placing all 4 of my queens in each of the corners. This is randomly generated. Now the second thing is evaluation. Now I'm going to check whether the initial solution I've taken won't cause me any ridges. What do I mean by ridges here? Ridges is a situation in which you will try to make changes or generate neighbors, but you keep getting the same heuristic value and you won't be able to proceed further with your solution. But you have to place your initial solution in such a way that you can bring the heuristic value to 0. So now let's start off by explaining the neighbor generation. So I'm going to be taking the first queen. So the queen can either go to this position, or this position. So initially I'm going to be placing this queen in this position. So if I place the queen here in this position, my heuristic value will change. It will become 8. Initially it was 12 because this queen will attack this queen, this queen, and this queen. So 3 attacks from this queen, similarly 3 attacks from this, 3 attacks from that, and 3 from this. So we get heuristic as 12. So our goal is to reduce the heuristic value. So what I have done, I have moved my queen to this position, and now my heuristic value has reduced to 8, because this time this queen will only attack this, but it will not attack anything else. The second, this queen will only attack this and this and this. So it's 3. This queen will attack this and this, 2. And this queen will attack these 2. So we have 8 total. 2 plus 3 plus 2 plus 1. So 8 total. So next, I won't automatically decide that that is my next move. In order to check whether that's my next move, I have to go through all 3 of these positions. So the next position I'm marking is this. So when I calculate the heuristic value this time, it's still 8. So I move on to the next one, which is this part. This time when I calculate, my heuristic value is still 8. So since all 3 positions is giving me 8, I can choose any one of the positions. So I've just decided on moving it here. Now, the second thing is, then again I have to generate neighbors, but this time for the new queen. This queen can either move here, here, or here. So, but I have uh, understood that if I move my queen here, my heuristic value has changed to 4. This is actually better than if you move the value, if you move your queen here or here, you can calculate and see that. But you can clearly see that when I move my queen here, my heuristic value is different and it's lesser. So I choose this positioning. The next I move my this queen to this position, and I notice that my heuristic value has decreased again. It has become 2. And then I will look at the next queen and I move my next queen here, and I've noticed that my heuristic value has become 0. That means no queen is attacking each other. So heuristic value is 0, and this is our final solution. So I can terminate. Thank you.